Hello and welcome to this video where I'll teach you how to describe motion graphs, especially velocity time graphs. Supposing you are given a sketch graph like this. On the y-axis we've got velocity, on the x-axis we've got time, and it's a straight line through the origin. How do you describe how this object is moving? How do we describe the motion of this object? When we are asked to describe how an object is moving, once we are provided with a sketch, what the examiner is looking for is for you to be able to use terms such as displacement, speed, velocity, acceleration, and you show how these are changing with time. Remember, you don't have to use all of them. You can just use one or two of these terms. So in order to understand how the velocity of this object is changing with the time, although this one is not always the case, I'm going to insert numbers. For example, I'm going to insert velocity at a rate of 5 meters per second. You can see from 0 to 5, then 10, 15, 20, 25, and 10. I could also have used 0, 10, 20, 30, 40. These are just values which I can be able to use, so long as when I use them, I make sure that one large box represents a given velocity. Like for example, one large box represents 5 meters per second. On the t-axis, one large box represents 1 second. Although this one are just by choice, you could choose any other values that you have there. So the interpretation is this: when time is 0, you can see that the velocity of the object is 0. So obviously this object is starting from rest. It is starting from rest. After 1 second, its velocity has increased to 5 meters per second. After another 1 second, its velocity has increased by another 5 meters per second to make a total of 10 meters per second, and so forth. Like you can see here, after another 1 second here, it has increased from 10 meters per second to 15 meters per second. So here we can see that the velocity of the object is increasing at a constant rate. The velocity of the object is increasing at a constant rate. What does that mean? It is increasing at a rate of 5 meters per second every second, or it is increasing by 5 meters per second every second. So when the velocity of an object increases, that object is said to be accelerating. So the acceleration of the object tells us how the velocity of the object increases in 1 second or changes in 1 second. For example, here the velocity of this object increases by 5 meters per second every second. So you can say that the acceleration of this object is uniform. So when we are given this graph, you can describe this object as an object which starts from rest and moves with uniform acceleration. Uniform acceleration. Because the acceleration is 5 meters per second every second. So you describe the movement of this object as, if you want to use the term acceleration, you can say this object starts from rest. By stating that it starts from rest, we are saying that its initial velocity is 0. And indeed you can see from this information here, when time is 0, the velocity is 0. But even if the values of t were not there, it would be possible to say that when time is 0, this quantity here is also 0. And since this quantity is velocity, we can say that when time is 0, velocity is 0. Such an object is said to start from rest. So this object starts from rest and moves with uniform acceleration. That is complete description of how this object is moving. If you want to use the term velocity in your description, you can say it starts from rest and moves with velocity which is increasing at a uniform rate, or at a uniform rate. So you can say that the velocity is increasing. And how is it increasing? It increasing at a uniform rate, because you can see it is increasing by 5 meters per second every second. So those are two terms that you can use for describing how this object A is moving. So remember, this one is an object which this one is an object which is moving from rest with uniform acceleration, or moving from rest with velocity which is increasing at a uniform rate. Okay, let's look at object B. Supposing we are given this object here, again we can see that the initial velocity is 0, so it starts from rest. Then how does its velocity increase? Let's check. In the first 1 second, it increases from 0 to 1 meter per second. In the first 1 second. In this next 1 second, its velocity increases from 1 meter per second all the way to 3 meters per second, because you can see at this point its velocity is 1 meter per second, and in the second its velocity is 3 meters per second. So its velocity has increased by 2 meters per second in 1 second. Let us check the increase in the next 1 second. So you can see this velocity here is 3 meters per second, and this is 6 meters per second. The difference between 3 and 6 is actually 3. So you can see that in this time interval of 1 second, its velocity has increased from 3 meters per second all the way to 6 meters per second. Its velocity has increased by 3 meters per second. So you can see that the velocity is not increasing at a uniform rate, as for the case of the first object. The first object, the velocity was increasing by 5 meters per second every second. But here you can see that the velocity of the object is not increasing at a uniform rate. Rather, it is increasing at an increasing rate. Check. From 0 to 1, then from 1 to 3, from 3 to 6, from 6 to 10, an increase of 4. You can say that the increase in velocity is increasing. So how would you describe the motion of this object using the term velocity? You can say object B starts from rest and moves with a velocity which is increasing at an increasing rate. I'm going to repeat that. It's very important. Object B starts from rest and moves with a velocity which is increasing at an increasing rate, because the rate at which the velocity is increasing is itself increasing. Check. It increases by 1, here it increases by 2, here it increases by 3, here it increases by 4, here it increases by 5, and you can see in fact this line is parallel to this one, showing that the increase in velocity is by 5 meters per second. Here it increases by 6 because it increases all the way from 15 meters per second to 21 meters per second. This one is very important to be able to describe the movement of such an object. So this object is not moving the same way as this object. Yes, both of them started from rest. Yes, both of them move with increasing velocity, and therefore they are accelerating. But the acceleration for A is not the same as the acceleration for B. While A moves with uniform acceleration or constant acceleration or the same acceleration of 5 meters per second squared, object B is moving with an acceleration which is increasing all by itself. So supposing these numbers were not there, how would we be able to tell that this acceleration is increasing? Or how would we be able to tell that the velocity is increasing at an increasing rate, while here the velocity is increasing at a uniform rate? How would we be able to tell if these numbers were not there? It's very simple. We use the concept of gradient. When we look at this straight line here, its gradient is uniform. But when we look at B, the gradient is increasing. That is the first thing that we use, gradient. And then we need to ask ourselves, what does the gradient of a velocity time graph represent? The gradient of a velocity time graph represents acceleration. So you'd be able to see that since here the gradient is constant, or it's uniform, or it is the same, it implies that the acceleration is also constant. Or you can use the word the acceleration is uniform, or you can use the word the acceleration is the same. How about B? Since the gradient of graph B is increasing, in other words, the graph is becoming steeper and steeper and steeper and steeper, then we can say since the gradient is increasing, then the physical quantity which is represented by the gradient is also increasing, and the physical quantity represented by the gradient of a velocity time graph is acceleration. So we are going to say that the acceleration of body B is increasing. So a complete description of the way object B is moving will say that the object starts from rest and moves with increasing acceleration. Notice that for A, the object started from rest and moved with uniform acceleration. How about body C? Let's check. It also started from rest, similar to A and B. It starts from rest because the velocity that it has when time is 0 is also 0. So we describe that one as the body starting from rest. Let's check. In the first 1 second, its velocity increases from 0 all the way to 7 meters per second. Okay? In the next 1 second, increases from 7 meters per second to 12 meters per second. And you can see the increase there is 6. Is it 6 meters per second? No. It's actually from this value we go to 1, 2, 3, 4, 5. It actually increases by 5 meters per second. In the next 1 second, it increases from 12 meters per second all the way to 16 meters per second. You can see that it has also increased by it has increased by 4 from 12 all the way to 16. It has increased by 4. So you can see that the increase in velocity is decreasing with the time, because here we had an increase of 7. Here it is an increase of, was it 6 or 5? It was an increase of 5. Here it was an increase of 4. Here it is an increase of 3. Here it is an increase of 2. Here it is an increase of 1. And here there is no increase. There is no increase. The velocity when time is 6 is the same as the velocity when time is 7. So here it is uniform, moving with uniform velocity. So how would you describe the motion of body C? You will say body C starts from rest and moves with an increasing velocity which is increasing at a decreasing rate and then maintains uniform velocity. It maintains uniform velocity. So here it is important you say it starts from rest and then the velocity moves or the velocity increases at a decreasing rate, and here you say it moves with uniform velocity. Remember that. If you wanted to use the term acceleration, you will say body C starts from rest and then moves with decreasing acceleration until after the 60th second its acceleration is zero. So that is how you would describe the motion of body A, B, and C. Remember, you actually don't need to have values on the axis in order to describe how the object is moving. I've given you a very good concept that you can always use if values have not been given. You just need to ask yourself, can I be able to tell how the gradient of this line is changing with the time? And you can see that the gradient is uniform. Can I tell how the gradient is changing with the time? And you can see the gradient is increasing. Here you can see the gradient is decreasing. In other words, it is becoming less and less steep. Okay, here the steepness is the same. Here the steepness is increasing. Here the steepness is decreasing. Since the steepness of a velocity time graph represents acceleration, you can therefore describe the acceleration of this object. You can say this one moves with uniform acceleration because the steepness is uniform. This one moves with increasing acceleration because the steepness is increasing, while this one moves with decreasing acceleration because the steepness is decreasing with time. In the next video, I'm going to give you, or we are going to learn how to describe more complicated velocity time graphs as well as displacement time graphs.